Hey there, are you an astronaut or somebody who travels through space? Then you know the importance of working out while being in microgravity. You may even work out up to 3 hours a day while you're in space.
Are you frustrated with your treadmill breaking down all the time or always having technical difficulties not allowing you to train?
Then we're here for you!
At FC, we're committed to solving your every space-related exercise need. We understand the inconvenience of calling Houston and whenever your equipment breaks down and how it affects your exercise schedule.
One of the serious side effects of going to space is the weakening of bones due to the progressive loss of bone mass. Bones are dynamic living tissue that constantly reshape in response to stresses around them. Under gravitational circumstances, like on Earth, cells called osteoblasts, shown here in red, build new bone, while osteoclast cells, shown here in blue, break down bone, and these two cells balance each other out, resulting in maintaining bone mass. However, in space, gravitational forces are much lower than the forces experienced on Earth, and there is less stress applied to your skeletal system. This reduced amount of stress on your bones, particularly in your lower extremities, causes the activity of osteoblast cells, the bone builders, to slow down, and therefore more bone tissue is broken down than built, resulting in a loss of bone mass. Some of the major health hazards associated with skeletal bone loss are accumulations of excess mineral in tissues such as the kidney, increased risk of fracture, and potentially irreversible damage to the skeleton. It is therefore important to provide a way for astronauts to apply loads on their body to prevent this bone loss. Most equipment currently used by astronauts is very complicated and prone to technical difficulties, which is why FC designed the AstroJump.
The AstroJump is small and lightweight with an area of 2.5 by 4 feet, consisting of a few parts and simple instructions. It's so easy to assemble that even a monkey can do it. The AstroJump was carefully designed for every space-related need. Our patented design allows for a lightweight machine that can be easily incorporated into any capsule on the space station. Dimensions are determined based on the maximum astronaut's height of 6'2", giving enough space for any astronaut that falls within this range. The platform is made of 2219 T6 aluminum, the most common material used for the structure of a spaceship. It is lightweight while also being strong.
In this finite element analysis, you can see that the platform does not deflect more than a micrometer. For simplification purposes, the analysis assumes a sorbothane layer around the perimeter of the platform.
AstroJump simulates high-impact exercises to help mitigate bone density loss. While on this device, the currently available super comfortable harness system is used to attach the user to the platform. Resistance bands made of natural rubber latex are attached to the harness system and the platform and produce a force equivalent to 1 Earth gravity. This diagram shows a model of the forces produced by the resistance bands. This is assuming an average male of 1.77 meters and 80 kilograms, and the band's attachment point is head-hips. To determine the tension, the body is simplified as a single point mass. Using simple statics and trigonometry, the tension needed in each strap is 400 newtons. However, resistance bands with various levels of resistive forces can be attached to accommodate for the individual's weight. With this design, it feels like you're jumping with a lightweight backpack.
You may ask, what about my delicate experiments in the adjacent capsule that can be ruined by excess vibrations? Fear not, because we use the best shock-absorbing material on the market, sorbothane. For best shock-absorbing and vibration isolation results, the maximum static deflection of the system should be less than 30%, with the worst-case scenario being that you land with all your weight on one corner. The max deflection of that one pad is only 7.7%. This was determined by using these static deflection equations shown here, verified by prototyping software from the company that makes sorbothane. With the 4x4x3 inch thick sorbothane pads on every corner mounted on the current TVIS system, the system is currently shock absorbent and transmits no vibrations to the surrounding structure of the space station.
If you call this number on your screen within the next 10 minutes, you will receive FC's AstroJump device, proven to maintain bone mass. It will also include a 20-minute workout and complete nutrition guide for absolutely free.
As you can see, the AstroJump is the solution to all your exercise problems in space. You can now get the AstroJump for only $1.5 million with 3 easy payments, which is $500,000 cheaper than the Goldberg treadmill.